Again, don't factor out of the 45, or you got to put it back into it at the end. Just factor out of the x's. Even if you want to move the 45 to the other side and get rid of it, that's absolutely fine. Don't lose this 3. That 3 has to come down. And don't divide out, because it's set to y. It's not set to 0. The only reason you can divide out is when you find your roots. Because your roots, it doesn't matter where your intercepts are. Your y-intercept is. You're just looking at your x-intercept. So the only time you can divide this by a 3 is when this is 0. Right now it's not. It's a y. So find your parts. Make sure I get all these pieces to it. Can everybody do this? Okay. Once you're in this mode, add the 3 to the other side, or if you've already moved it to the other side, it's even better. Divide both sides by 3. Take the square root. The one thing to remember, don't forget you get the plus or minus. Now, if you end up over here, like this, you have to resolve that. Because you can resolve this. You can simplify this. If this had a radical and you just move the 4, that's fine. But when you get to here, you have to break them down and give me the intercepts. And again, check it on your calc. You can put this in your calculator and check it. This 3, you can see this 3, your y-intercept is way, way up here because this is much, much narrower. This is your vertical stretch. You can see your transformations at work. Your shift left and down. There's where your vertex is. So your transformations really, really help once you get to this point. Somebody else is working? Okay. All right, let's go to the next one. Okay, again, just factor it out of the x's. Leave the other one alone. Move it to the other side, whatever you like to do to it. Complete your square. This negative reflects it. This 2 stretches it. It's moved from 3 to the right, 2 up. So there's your vertex. Your axis of symmetry again cuts through your vertex points. It cuts through this x value. So therefore, x is equal to whatever this h is. So x is equal to 3. That's your axis of symmetry. You don't have to use your negative b over 2a because you can take it right off of this. Increasing, everybody go with the increasing, decreasing part. Remember to give me increasing, decreasing by x values. It's when your y is increasing, then your y is decreasing over that x interval. Yeah. Keep it up, sure. Yeah. Ask me whatever. We can redo the complete the square if you didn't get the complete the square. I post up all the answers worked out, but if at any time you say, I still don't get that, we will work it out from the beginning because you need to be able to do these. A lot of times I bore you because most of you have it, but the rest got to speak to me. Tell me what you don't have. Again, your zeros, your y-intercept is easy. Do this part, there's your y-intercept. Just show me that you put the zeros in because you have to show me algebraically. Always just show me a substitution. Substitute, get your y. Substitute it into here, divide this through, and at this point you can resolve these guys as well. And check them on your calculator. Those are nice to check. Another thing that you can do if you're not sure that you complete the square worked is put this in y1 and put this guy in y2. You didn't change the equation. You just transformed it to another format. So they have to be the same graph. So after you complete the square, before you go through and do the whole thing, put it in y1 and y2. Make sure they are the same graph. And it gives you a little bit more confidence, and then you go through it And if at any point, God bless you, if at any point your intercepts, if my y-intercept showed me being at 0, 16, and mine is turning this way, I would say, whoops, what did I do wrong? They have to match together. So I would look at it. Oh, I forgot my negative sign here, so this really was a negative 16. Or, oh, I was supposed to turn up the other way. So make sure it will make sense to you. Good. Okay. This one we worked on completing the square yesterday. We started it, right? Watch that fraction. When you have 2x squared plus 2x and you factor out a 2, you divide by 2. So now you're dividing by 1/2. You're dividing this by 1/2. You're dividing this by 1/2. Keep, change, flip that fraction. That becomes 4. That's a common mistake. We see, oh, just take half of 2. It's 2 divided by 1/2. And then keep on going with this. Don't forget to factor this, distribute this out to get it out there. Okay, your zeros, once you get to this point and you divide, as if you take the square root of a negative, just stop right there. Don't pull out the I, just tell me no real roots. The only time we work with the I, you'll have to find the I. But everything else, we just say no real roots. Again, here's your intercept, 0, 6. Oh, you can. If you plug in 0 for y in here, so can you factor that? So you divided by 1/2 to get rid of this? So this becomes a 0. And then you factored that? That's fine. For the zeros, you can do that. Oh, okay, so what did we do wrong here? You divide by 1/2. Good question. Well, this isn't factorable. What factors did you get for this? What were your factors? So how did you do it? Ah, but that gives you a different middle number. So if you graph this guy, you're going to see that graph over there. Yeah. I mean, and it would be doable if, in fact, it did have roots. And we can tell that it doesn't have roots here because we can't factor it. But the thing about the complete the square, once you're at this point, if you can't factor something, you're going to have to use a quadratic formula. But if you're here, just set it equal to 0 and use that format. It makes life so much easier. There's no quadratic formula. You can go back and use the quadratic formula, or sometimes we complete the square and you could say, oh, I could have easily factored. You could easily factor. Just in that format, it makes life a little bit easier. Okay, here's the fraction. So, put my 0 term here if it helps. Start like that. Okay, I've got to factor this out. I'm going to factor out 1/2. I'm going to be left with x squared plus what? Plus 0. And I'm going to do something here, minus 4, and do something here. What's half a 0? 0. So I could do like this if I want to, just to make life easier. 0 squared, there's a 0, and you come out the same way. Just put the 0 in if the pattern, the routine is still the same. And we're back to where we started from. And that's your complete the square. That is as good as you're going to get. You have no transformation here, so it stayed at the 0, right? There's no shift. But where's my shift? Down 4. What's my 1/2 tell me? Vertical shrink. So I got a little wider in my parabola. I can graph right off of this. There's your transformations. You come out to the same exact thing. If it troubled you looking at a fraction, and it's the same thing. Maybe this helps this way. You can see your transformation a little bit better. Your zeros. Oh, another thing, always make sure you simplify fractions to lowest terms, you simplify radicals. We don't have to rationalize denominators, but you do have to simplify radicals. That's like a given. We don't even say that in the directions. Yes. All right, so we have, it looks like a little bit of a systems of equations here because we're going to do two things. And we're going to actually put this in your calculator to graph this. We're going to find two positive real numbers. We're going to start out real easy that satisfy whatever it is we're looking for, a maximum or a minimum. Now, if we're looking for a maximum, which way do you think your parabola turns? Down. So our parabola is going to turn down, and we're going to find this maximum up here. So this maximum is this x and y. If we're looking for a minimum, generally it's going to turn and it's going to have a little slant to it. This is a minimum. Okay. Now, we're going to play with this a little bit. We're going to use the values of x and y. However, our x and y are going to be a little bit different than this y. This y is the y that comes from your equation, and we'll get to that in a second. Whatever we maximize or minimize is going to go in your y1. If we say maximize, it's a product, it's going to go in your y1. If we say minimize, it'll be like a perimeter, it'll go in your it'll go in your y1. If you're looking at this is where this comes in handy. Say you're a rancher and you have a lot of land, and you're going to put a fence around your land. So you've got a certain amount of area that you can farm on. Say you have, let's just say you have 48 square miles, whatever, 48 square miles of yard. Well, let's just do 48 yards right now. So say your area is 48. You can set it up a number of different ways. You could set it up, give me two products of 48. 12 and 4. So you can go like this, a 12 by 4. What's another way you could set it up? 6 by 8. So a little bit closer on the sides and everything. So you can set this up. Now, because you have to pay for this fencing, you want to spend a lot of money or the least amount of money on your fence? The least possible. So would you want to minimize your area or would you want to minimize your perimeter? Perimeter. You want the area to stay the same. I want to maximize my area, but I want to minimize my perimeter. So this is where this is coming into play. Right now we're working with numbers, and I always find it a little harder when we start with the numbers because they don't really have like a scenario behind it, like why am I maximizing this? But in reality, when we turn around and we hit the ranchers and we build the fences, they kind of make a little bit more sense. So we're going to remember that our product is going to be maximized, our perimeters are going to be minimized. And whatever we maximize or minimize is going to go into Y1. Okay? And we're going to depend on your graph for this. And you know how to get these. This is your second, your calc maximum, your calc minimum, right? And how many decimals do we round to? 3 decimals. Okay. So let's start. I have two positive real numbers. The reason we start with the positive real is because when we do the applications for these, they can't be negative. The sum is 110, and the product is a maximum. So let's start with your let statement. And we're going to let y equal your second number. How do I use x and y and get a formula for the sun? An equation for the sun. Oh, number, sorry. You're not used to my sloppy handwriting yet?
No, I was looking at it and I was really
I write as I'm saying things, so I kind of abbreviate along the way. I figured now with everybody text messaging, you're really good at abbreviations. And it's getting better. So how do I say this in terms of x and y? X plus y equals 110. How do I set up a product for that? xy equals something, right? So right now I'm just going to say y1 because I'm going to put that in my y1. But I have a little problem. When I go to my y1, I can put an x in, but I can't put the y in there. So therefore, if I solve for y in terms of x, I can substitute that into there. So solve for the y in terms of the x. So we're going to subtract x from both sides. Agree? Now I can take this out and replace this. This is going to go in my y1. Now don't graph it yet. Let me just explain something. See this y1? That's this y1. When we get this, that's this y1. Right? Isn't that where your y comes from when you do a max from your y1, whatever was in your y's? Okay. That's not this y. So in your calculator, what value are we going to find? X. And then we're going to have to bring it back and find that y. So let's graph this in your calculator. You're going to have to play with your windows a little bit. You guys good with windows? Sure. You'll get to be a pro with your windows after this. So. Now, if you just graph this regularly, you probably don't see it. So let's talk a little bit. If these are two positive real numbers, what should I right away start with? Okay, go to my minimums. Zeros. Shouldn't both my minimums be zeros? Because aren't I positive numbers? So right away my minimum should be 0. What quadrant does that put me in? First quadrant. I can't have any negatives here, right? So I think of two numbers that add up to 100, 110, but my product is what's going to represent my y. Now, you have a couple of ways to do this. You could go to your table. Maybe. You could go to your table. Maybe you could go to your table and look at your table. I can't look. Oh, there it goes. I want to see, we said this is a maximum. So what is it I'm looking for? For it to go back down. Good. I'm going up, 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 and then I'm going to come back down. Whoops. It doesn't like when I hit this too many times. So let's just keep on going a little bit until we see it turn back down. You don't have to be exact. Okay. So somewhere over here, I came up, 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 and then I stopped and I turned down. Somewhere at 60. Don't have to be exact. If x is 60, what should I put in for my max x for my window? Well, I want to probably do a little bit more. Don't I have to look at the top one, right? So maybe make it like 75. This is a window. This is not your solution. Now, when we looked at this, if I can look at it again. My y value, we're somewhere over the 3,000, right? So I'm just going to say, okay, my y max make it 3,500. I want to be able to see the top of it. And then graph. You need to be able to see this turn. Do I really need to see it hit the ground? No, I need to be able to see it turn. I can change my X. Why did I not make it with my X if I saw it turn at 60? Why did it not work? Why don't I see it hit the ground? What did 60 represent? The highest point, right? So if we wanted to see it hit the ground, what should we do to 60? Double it. But that's okay. I just need to see it turn. Do I know it's coming back down? Absolutely. If you want to, just always take where the turning point is and just double it and give yourself a little bit more. Only because when you do a max, you're going to be so far at the top, sometimes it doesn't show up when you do the max. But that's okay, as long as you see a turn. So now we're going to do this. We're going to do a second count. Don't do a trace, do a max. If you want to set your numbers up or you just want to move your little bug thing, either way you go. My calculator doesn't always cooperate up here. Okay, and remember, your calculator does a little bit of weird things. So, what's my X value? My X value is coming up here. It's turning at 55. And my Y value is 3,025. Okay, so let's talk about this for a minute. What does 55 represent? The X. Good. What does 3,025 represent? Which Y?
Y1.
Y1. And what is in Y1? The maximum product. This is my product, my maximum product. This is important because this Y is not that Y. This is what we've put into your Y1. This is your product. So we take this X and we bring it back over here. And we find out, oh, lo and behold, Y is also 55. Okay, we found out both of them to be 55. Now, if they ask for what your maximum, well, this is just not really a scenario here, it's just two numbers. If they ask for what your product is, that's sitting in your Y1. But these are your two values from your let statement. These are your two positive numbers that give you a maximum product, right? And they sum up to 110. Good. This is a good exercise with your windows as well, because you really have to keep adjusting your windows. You're always going to set your minimums to 0 because you want to be in the first quadrant. We're not going to have negative numbers in there. Your maximums, you don't have to go to your table. You just guesstimate a little bit. If you figure out the halfway mark, multiply 50 times 50, and guesstimate where it is, go a little higher, you'll be fine. You'll see there's different ways to kind of get around that. Okay. Let's try another one. We have the same two numbers. We have the same two let statements. Does yours say the whole thing over? No, it just says this. Okay, so again, let Y equal the first positive number. Oh, let S equal the first, let Y equal the second. Somebody humming? Who's humming? What is that coming from? The heater? Or somebody humming? Sounds like a humming. So how do I represent this? The product, how do I put this in an equation? The product is 192. X times Y equals 192. Good. And the sum is a minimum. This guy is going in my Y1. This is going to represent my sum. So how do I represent the sum of my two numbers? X plus Y. Okay. Now, I go to put this in my y1 and I say, whoops, I can't put a y in there. So I come back here and I say, let me solve for y in terms of x. So how do I solve for y in terms of x? Divide by x. I'm going to take this and I'm going to substitute it right into this guy. And that's what's going to go in, oh, I left it out there. And that's what's going to go into your y1. Well, let's play with this a little bit. Let's see if we could do this without even looking at our window. Let's try it. Think about it for a second. Oops. Get my divide out here. Let me graph it and see what happened to it since I had my other window up there. Not seeing very much. So let me think about this for a second. If I have two numbers that multiply to 192, so let me just round it to like 200. Let's think of like the square root of 200. We'll be close to the square root of 200. Hundred is 10 and 10, right? 144 is 12 and 12. So maybe like 15 is what, 225, somewhere around there. So maybe I say 15, and I'm just saying, you can just start guesstimating, play with your windows a little bit. This is not going to work for me. Again, I'm always at the 0. My x max, maybe it's 20. Well, maybe my y max, I'm just going to put 20 in for here, just for the heck of it, just to see what this looks like. And then I'm going to graph it. Do I see anything? So what else could I do? Like, where would you start? Is what I'm asking you. Where would you start? Without looking at the table. 100. Okay, let's try 100. 100 where? At the max? And the y max also? What is my max? My max is a sum, right? Okay. My y max is a sum. Ah, much better. So sometimes you can kind of think about the scenario. It works a little bit better when you start looking at the areas and the perimeters because they do make more sense. You can kind of like figure them out a little bit better. Sometimes you can just play with your window and you can see it. All else fails, go to your table. What happens with the minimum? I'm going to start back at the 0, hopefully. What happens with a minimum in my table? It's going to go down and then turn and come back up again, right? I just can't get to my table here. There it goes. It's going to go down, 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 and come back up again. So I see it coming down, but I haven't seen it come back up again. Still going down. Oops, came back up. Somewhere over here, so somewhere like 16, 20. That's halfway through, right? The minimum matters. Because if my minimum is only halfway through, double that. Just find your x and always double it. Your x is halfway when you find that turning point, right? So always get to the x and double it. So I'm going to double 20, and I'm going to make my x be 40. This guy here is just my minimum. I need my y maximum, don't forget. My y minimum is set at 0. So my y maximum, somewhere up there, I'll just make it 50. So whatever you want to do, if you make this, would we say double 20 to make this 40 or 50? You can make it 50, and you can make this one be, what did we say, 50 also? Whatever it is that you can see your graph turn. Okay? You need to find this minimum point. Notice what this looks like. There's actually another part to this, because you've got an inverse thing going on. Okay? But all we care about is this minimum. So do your minimum on here. Don't get hung up on your windows. You can always go back to your table. When we get to the large numbers, you're not going to want to put your finger there and keep scrolling. You know how to start your table set at another number. Start your table set further down. Just jump on it. Just set it at a different number. So find your minimum. This is really a nice exercise also in helping you get used to your calculator. You can't do anything wrong. If you do anything wrong, Zoom 6 and start all over again. Sometimes kids get a little frustrated, like I can't see my graph, I don't know where it went. Zoom 6 and start again. And in that case, go to your table and look for it. So we're looking for your minimum value. So my minimum value, when I graph this, I see a minimum, and this minimum value is 13, how many decimals? 3. Okay? So tell me what this represents. What does this X represent? The first positive number. What does this Y represent? Y1, which is what? My sum. So how do I find the other Y? Bring this X back in here. Substitute it in. You'll get used to it with the Y. The only thing that's confusing is probably the Y part. But you'll get a little bit better looking at this. When you look at your minimum or your maximum, remember that Y is your Y1. So that's my minimum sum, because there'll be some questions that will say to you, what's your minimum product, what's your maximum product, and this becomes, all right, all I want you to do, wait, what's Y? Same thing. No, all I want you to do is number 3 and 4, and then get a good rest. Just two that are just like this. 3 and 4. You okay? Yeah. Oh, okay. No, you're fine. Right. I started 9 o'clock. Well, what time? I have the money. I'm getting my stuff. I have jobs so far. Good. The only thing I haven't been looking at Tuesday. That's why I do I'm crazy with time, and I'm a very hard to sit down and do tasking. One thought, one Good, how are you? Yeah. Yes, she does, yeah. No, but I sure will. Okay, all right, I got it. They're good. They all think they're good. I thought your math grades were, they dropped. Yes, they dropped. But they were real good. Your abilities are good. But don't you little think about it. Do your little thing back there so that and it does make you more mindful. No, I know. You also will use this Craig and everything else. And you will walk in this way.
43,
Well,
44.
sometimes moms don't understand that. Absolutely. It's not that we don't understand it. It's just, say sometimes we say, well, you're a kid, you'll get over it. Yeah. That's what drives your world. So sometimes as a mom, you have to say, okay, I've specified, I want you to do this. So, because sometimes if we think that we're feeding, we do that. So, moms have to where they are understanding as well. So let's I'm gonna send you. I'm gonna have you send you some list of things that you need to make up. My grandson, he's the love of my life. You will have a tough life, and he's the love of my life. So your unscored signs, I'm gonna have you send. These are the ones that are just unscored right now. They kind of go pretty far back. So let's have you just put your email on it.
That's how
Most of the time I figure out I excuse it if it is, but you're absolutely
They are, they're supposed to be, my mother never,
they don't.
I know, they won't.
Some of them don't have symptoms.
They should be, but.
See, these guys, they were an excuse, so zeros, there's a lot of them.
They all should be.
I'm gonna send you this whole thing as well. So if you wanna go to the zeros and make those up.
I should have.
What do you want? Alright, let's get back on track. Good.
I see it a little bit. You can't say all that? Just hilarious. I know, it's just
Yes. You put percents. You gave me percents. This is your frequency. I didn't take off there, I took off this.
okay.
And I circled that to say, you can pick up. Two rounds.
131. I will. Thank you. Appreciate it.
All right, teacher, I did again. So it's my turn.
What was it, that's me? Did I get that? I'll look it up,
Liars.
Right.
Say, because she got her colors changed. Yeah, I know. I literally told the girl every day.
Okay.
I'm not even.
Am I still recording?